Out for takeoff, and we're ready to run up the engines to check them out and make sure that they're airworthy for our flight. As we pull up in position, we'll stop and we'll lock the tail wheel. And we need to lock the tail wheel as we've just completed rolling the last, say 4, 5, 6 feet to ensure that the tail wheel has locked. Otherwise, the tail wheel could be castered, and even though the handle is in the locked position, the tail wheel would really not be locked. So by doing it as you're rolling those last couple of feet and you know that you're rolling straight, you can ensure that the tail wheel is locked. At that point, we'd set the parking brakes by depressing the rudder pedals or the toe brakes and grab a hold of the parking brake handle down on the bottom of the console and pull it out. Take your feet off the rudder pedals. Toe brakes, actually. At that point, we'll make sure that our engine RPM is stabilized somewhere between 1,000 and 1,200 RPM, depending on temperatures. We check that our mixture controls are set in the auto lean position. We'll look at our temperatures and pressures, see where we're at. Our oil temperature should be, to have taxied, it should be out of the red and somewhere around at least the 50 degrees centigrade range. And our cylinder head temperature should be in the green arc, and our oil pressure should be reading somewhere around 80 to 85 pounds. We'll check our fuel selectors and make sure that they're on the main tanks, left tank, right tanks. At this point, we're satisfied with our temperatures. We'll go ahead and advance the throttles and bring the RPM to 1,700 RPM. Stabilized at 1,700 RPM, the pilot will grab both propeller controls and bring them all the way to the full aft position, at which point the RPM should decrease to somewhere around 1,200 RPM. Once they've stabilized there, return the propeller controls to the full high RPM and watch them come back up to 1,700 RPM. This tells us that our governors are functioning properly. The next is to do a feather check. On the overhead console is the feather buttons. We push feather 1, and we'll notice about a 200 to 300 RPM drop. At that point, we release the feather button manually. Do the same for the right engine. Push the feather button, watch for the 200 to 300 RPM drop, and then pull the feather button back out. Watch the RPM return to 1,700 RPM. Now we'll cycle the propellers one more time by bringing the levers all the way to the full aft position. This will tell us that our feather buttons have released and are out of the circuit, and that our governor is back in control of the engines. Return the propeller controls to the full high RPM position, and we'll see the RPM go back up to 1,700 RPM. While we've done all this, we've observed our generators over here. We've got load meters, making sure that the generators are actually functioning and cutting in and out at the various RPMs. Typically, in this airplane, the generator cut-in speed is around 1,200 RPM. We're going to look at them and just see that we have a load. So that tells us the output is happening. Next would be to check the magnetos, and we would do that. I'll just go ahead and turn this all on for now. We'd check the magnetos one engine at a time. We advance the throttle until we get 30 inches of manifold pressure, or the field barometer. If you're at sea level, typically we would run the engine up to 30 inches of manifold pressure. If you were at a field that was 2,000 feet high, you would lose an inch of manifold pressure for each 1,000 feet. So at that point, you would only run it up to 28 inches of manifold pressure. That would be typically the standard pressure at that altitude. So we've advanced the throttles, we've run the manifold pressure up to 30 inches, and we've checked our pressures, they look fine. We take the magneto and we go from the both position to the left position momentarily. We should see a 25 to 50 RPM drop. We go back to both, we see the RPM come back to its where it was originally. Now we check the right position. We see the 25 to 50 RPM drop. We come back to both, and that engine has been checked. We can bring that throttle back down to the 1000 RPM. Repeat the procedure with the left engine by pushing the left throttle up and go through the entire sequence again. We also check the carburetor heat, which isn't a lot in this particular model of airplane. Carburetor heat controls are over here on the right hand side. We have a lock handle which goes forward to the instrument panel to unlock them, and we've got two handles which move forward and aft, center position being off or cold and forward being heat. The aft position in this airplane is a filtered position, since this has what they call the large or tropical air scoops. And with the carburetor heat functioning properly, we would see a slight drop in the manifold pressure. And that really completes the run-up.
Okay.